Hi friends, I am Rajesh, MSc Mathematics. Welcome to RecTV Education. Today I am discussing the topic Basic Proportionality Theorem or Thale's Theorem. Statement: if a line is drawn parallel to one side of a triangle to intersect the other two sides in two distinct points, then the other two sides are divided in the same ratio. This is a statement. Before learning this theorem, we have to learn two concepts. First one, area of the triangle. So consider this is a triangle ABC. Now this is the altitude from A to the base BC. AD is the altitude. Now area of this triangle is equal to half into base into height. Half into base is BC into height AD. If the triangle is like this, that means obtuse angle triangle. So if this is the triangle, so PQR. To find the area for this triangle, if you consider this QP, what is the height? So if this is the base, what is the height? How can you construct the height? First, you have to extend this QP like this and draw a perpendicular from this R. Now this becomes the altitude, height of this triangle with respect to the base QP. So, and this is S. Now RS becomes the height of this triangle if QP is the base. Our next concept, these two are parallel lines. The two triangles lies on the same base. So here this is one triangle and this is another triangle. Now ABC is one triangle and ABD is the second triangle. These two triangles lies on the same base AB and between the same parallels AB and CD. The area of triangle ABC is equal to area of triangle ABD. Let ABC be the given triangle. So this is A, this is B and this is C. Now consider a line DE that is parallel to the line BC. So here given that any line which is drawn parallel to one side of a triangle to this side BC, so that divides other two sides at two distinct points, that means D and E, intersects the other two sides in the same ratio. That means here we have to prove that AD divided by DB is equal to AE divided by EC. So RTP required to prove AD divided by DB is equal to AE divided by EC. So here construction, we have to join this DC and BE. You have to join here this DC and this BE. And to find the area of this upper triangle ADE, we have to construct a perpendicular line from this E to the base AD. Now this EM becomes the altitude from E to the base AD in triangle ADE. So here first consider area of triangle ADE is equal to half into base into height. If we take the base is equal to AD, that means this is AD. So AD, now the height is equal to EM. And in the second case, we have to consider this triangle. So just this triangle we have to consider. Triangle BDE. Area of triangle BDE, if you consider DB as the base, now this becomes an obtuse angle triangle. Here for this triangle, if you consider DB as the base, ME becomes the height. So for the extended line of BD, so here ME is the perpendicular line. Now for this base BD, ME becomes the altitude. So that means area of triangle BDE is equal to half into, if you consider this base dB, the height becomes me or em, anything we can write. Now we have to take the ratio of these two triangles. So area of triangle ADE divided by area of triangle BDE, ratio we have to take, that is equal to half into AD into EM divided by, so here this area ratio, so half into dB into EM. Now EM cancel, so half will go, that is equal to AD divided by dB. From this implies area of triangle ADE divided by area of triangle BDE is equal to AD divided by dB. So this is equation number 1. Now that is equation number 1. Step 2. In the next step, again we have to consider area of the triangle ADE, but here we are taking the base AE. For this base AE, I am constructing a perpendicular, that means altitude, from the vertex D to the base AE. So now this becomes the altitude. So area of the triangle ADE, area of triangle ADE is equal to half into, now I am considering the base AE into height, now this is n, is equal to, height is equal to dn. Again from the triangle DEC, this is also an obtuse angle triangle. To find the area of this one, so if I consider this EC as the base, and for this dn becomes the altitude. So area of triangle DEC is equal to half into, base is EC into height dn again. So now the ratio of these two triangle areas, area of triangle ADE divided by area of triangle DEC, that is equal to half into AE into DN divided by half into EC into DN. Both D and DN will go, half will go, that is equal to AE divided by EC. So from this, area of triangle ADE divided by area of triangle DEC, that is equal to AE divided by EC. Now this is equation number 2. Step 3. From these two triangles DBE and DCE, these two triangles lies on the same base DE and between the same parallels DE and BC. Now area of triangle BDE is equal to CDE. That means triangle BDE and triangle CDE both lies on same base and between parallels. Parallel lines implies area of triangle BDE is equal to area of triangle CDE. We can divide both the equals by equal number. That means if you divide these two by the same area, that is area of triangle ADE, so we will get area of triangle BDE divided by area of triangle ADE, that is equal to area of triangle CDE divided by area of triangle ADE. We can reverse both the sides, implies area of triangle ADE divided by area of triangle BDE, that is equal to area of triangle ADE divided by area of triangle CDE. From equations 1 and 2, first one, this ratio is equal to AD by DB and second ratio is equal to AE by EC, implies we can write AD divided by DB is equal to AE divided by EC. Now this is the result. AD by DB is equal to AE by AC, hence proved. Now I am discussing converse of basic proportionality theorem. Statement: if a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. Let ABC be the given triangle ABC. Given statement is, if a line divides any two sides of a triangle in the same ratio, that means, so I am considering a line DE here. So DE divides the other two sides AB and AC in the same ratio, means AD divided by DB is equal to AE divided by EC. So first given AD divided by DB is equal to AE divided by EC. So here RTP required to prove is DE is parallel to BC. We have to prove this one. To prove this theorem, we are following contradiction method. Let E dash be the point on AC. Now I am considering that DE is not parallel to the line BC. One more line is there, that is DE dash. DE dash is parallel to BC. By construction, DE is not parallel to BC. So this is assumption now. Now DE dash is parallel to BC. DE dash is parallel to BC. So this is our assumption. So by using basic proportionality theorem, DE dash is parallel to the side BC. That means DE dash divides the other two sides in the same ratio. That means AD divided by DB is equal to AE dash divided by E dash C. By using basic proportionality theorem, AD divided by DB is equal to AE dash divided by E dash C. This is equation number 1. And next one, given thing AD divided by DB is equal to AE divided by EC. This is equation number 2. This is the given value. This is from basic proportionality theorem. We got two relations here. From these two relations, we can observe that AD by DB, here also AD by DB, both the LHS are same. We have to equate these two RHS. So AE dash divided by E dash C is equal to AE divided by EC. Now from these two, AE dash divided by E dash C is equal to AE divided by EC. Now AE dash divided by E dash C is equal to AE divided by EC. We have to reverse this both. E dash C divided by AE dash is equal to EC divided by AE. Now we have to add E dash C by AE dash C. For this we have to add plus 1. And this side also EC divided by AE, so plus 1. Take LCM. Now E dash C plus AE dash divided by AE dash is equal to EC plus AE divided by AE. So EC dash EC E dash C plus AE dash. So that means this value plus this value. The AE dash plus E dash C is nothing but AC. AC divided by AE dash is equal to now EC plus AE. These two values. That is also equal to AC. AC divided by AE. Now these two values are same. AC will go. From this AE dash is equal to AE. AE dash is equal to AE. This is the contradiction. So here this contradiction arises due to our wrong assumption. So to keep this one, E dash must coincide with E. Now that means E dash is equal to E. That means the line DE is parallel to BC. So here A dash is equal to E. This contradiction arises due to our wrong assumption. So that means E dash must coincide with E, implies DE dash is same as DE. So that means DE is parallel to BC. Henceforth, from the given figure, if LM is parallel to CB, LM, so this one, LM is parallel to CB, these two lines are parallel, and LN is parallel to CD, LN, this is parallel to CD. From this we have to prove AM by AB, AM divided by AB is equal to AN divided by AD. First, given LM is parallel to CB. From triangle ABC, LM is parallel to CB. That means AM divided by MB is equal to AL divided by LC. So here from this triangle, LM is parallel to CB. That means these two lines are parallel. By using basic proportionality theorem, AM divided by MB is equal to AL divided by LC. And again he gave that LN is parallel to CD. From triangle ADC, LN is parallel to CD, implies these two sides are parallel. DN divided by NA is equal to CL divided by LA. So that means DN divided by NA is equal to CL divided by LA. Just here we got equation 1 and this is 2. So we have to reverse this one. That means AN divided by ND is equal to AL divided by LC. This is equation number 2. From 1 and 2 we can observe that both the RHS are equal. AL by LC, here also AL by LC. From equations 1 and 2, AM divided by MB is equal to AN divided by ND. But we have to prove that AM divided by AB. So here AM is there but MB is not there. We have to reverse these two. So that means MB divided by AM is equal to ND divided by AN. Reverse the result. For this one we have to add plus 1. MB divided by AM plus 1 is equal to ND divided by AN plus 1. We have to add 1 on both sides. Now by taking LCM, MB plus AM divided by AM is equal to ND plus AN divided by AN. Now from this diagram, MB plus AM, so this is the total value, that is AB divided by AM is equal to ND plus AN. So this is equal to totally AD divided by AN. So we can reverse this one, implies AM divided by AB is equal to AN divided by AD. This is the result. Question number 2. In the given figure, if DE is parallel to AC, DE, we have to join this one, DE is parallel to AC. These two lines are parallel. And DF is parallel to AE. Then prove that BF divided by FE is equal to BE divided by EC. Just here we have to observe that BF and FE, these two values. These two values lies in this triangle BEA. BEA. From triangle BEA, DF is parallel to AE. Now these two lines are parallel. That means DF divides the other two sides in the same ratio. This is the basic proportionality theorem. EF divided by FB is equal to AD divided by DB. This is equation number 1. Now, from triangle ABE, DF is parallel to AE. DF is parallel to AE. So this is given information. And by using basic proportionality theorem, DF is parallel to AE implies EF by FB is equal to AD divided by DB. That means EF divided by FB is equal to AD divided by DB. This is equation number 1. And next this side, that means BE and EC. So here next one is BE and EC. BE and EC both involved in the RHS, and DE is parallel to AC. That means we have to consider the total triangle ABC. Now from triangle ABC, DE is parallel to AC. This is given information, and by using basic proportionality theorem, so these two lines are parallel means CE divided by EB. CE divided by EB is equal to AD divided by DB. Equation number 2. So here the reason is basic proportionality theorem. So here also basic proportionality theorem. From equations 1 and 2, we can say that here AD by DB is equal to this value, AD by DB is equal to this value. Now we have to equate these two. That means EF divided by FB is equal to CE divided by EB. So reverse, we have to prove this one. That means exactly reverse. So that means BF divided by FE is equal to BE divided by EC. This is the result. Question number 3. In the given figure, DE is parallel to OQ. That means this DE is parallel to OQ, and DF is parallel to OR. DF is parallel to OR. Prove that EF is parallel to QR. We have to prove that these two sides EF is parallel to QR. Now consider this triangle QOP. DE is parallel to OQ. By using basic proportionality theorem, QE divided by EP is equal to OD divided by DP. From triangle QOP, ED is parallel to QO. This is given information. From this we can write QE divided by EP. QE divided by EP is equal to OD divided by DP by using basic proportionality theorem. This is equation number 1. Now just you consider this triangle, second triangle. In this DF is parallel to OR and OD divided by DP is equal to RF divided by FP. Now from triangle ROP, DF is parallel to OR. This is a given information. And from basic proportionality theorem, these two sides are parallel. OD divided by DP. OD divided by DP is equal to RF divided by FP. RF divided by FP. This is equation 2 from basic proportionality theorem. From 1 and 2 we can write OD by DP is equal to this value. Here also OD by this value is equal to this one. From these two equations we can say that QE by EP is equal to RF divided by FP. From equation 1 and 2, QE divided by EP is equal to RF divided by FP. Now just QE divided by EP is equal to RF divided by FP implies EF divides the two sides in same proportion, that means in the same ratio. So here EF divides these two sides in the same ratio, that is QE by EP is equal to RF by FP. Just now we got that one. So by using converse of basic proportionality theorem, EF is parallel to QR. EF is parallel to QR. Here converse of basic proportionality theorem. So this is the result. Question number 4. In the given figure, A, B, C are points on OP, OQ and OR such that AB is parallel to PQ. So here AB is there. This line is parallel to PQ. And AC is parallel to PR. AC, this is parallel to this one. We have to show that BC is parallel to QR. Now the given information is AB is parallel to PQ. We have to consider this triangle. So OQP. Now AB is parallel to PQ implies PA divided by AO is equal to QB divided by BO by using basic proportionality theorem. So from triangle OPQ, AB is parallel to PQ. So this is the given information. So implies PA divided by AO is equal to QB divided by BO. This is equation number 1. This we got from BPT, basic proportionality theorem. Next given information, AC is parallel to PR. We have to consider this triangle POR. From triangle POR, so AC is parallel to PR. So this is the given information. From this we can write PA divided by AO is equal to RC divided by CO. This we got from basic proportionality theorem. This is equation number 2. By observing equation 1 and 2, so here both these values equal to this QB by BO and RC by CO. Now these two values are equal. Implies from equation 1 and equation 2, QB divided by BO is equal to RC divided by CO. Now this QB divided by BO is equal to RC divided by CO. From this triangle OQR, if we apply converse of BPT, BC is parallel to QR. From triangle OQR, QB divided by BO is equal to RC divided by CO, implies BC divides the two sides in the same ratio. So implies BC is parallel to QR. This one we got from Converse of BPT. This is the required result. Question number 5. ABCD is a trapezium in which AB is parallel to DC and its diagonals intersect each other at the point O. Then show that AO divided by BO is equal to CO divided by DO. For this, we have to draw a trapezium. In trapezium, one pair of opposite sides are parallel. Here this is A, B, C, D. This is the given trapezium in which AB is parallel to DC. This side is parallel to this DC and its diagonals intersect at the point O. Here this is the point O. From this diagram we have to prove AO divided by BO is equal to CO divided by DO. For this we have to construct a parallel line to DC. This is parallel line. Now let this is equal to E. Construction. EO is parallel to AB and AB is parallel to DC. This is given thing. From these two we can say that EO is parallel to AB, that is parallel to DC. Now from triangle, first we have to consider ABD. From triangle ABD, now EO is parallel to AB. EO is parallel to AB. From this we can write AE divided by ED is equal to BO divided by OD. Basic proportionality theorem. AE divided by ED is equal to BO divided by OD. This is equation number 1. This we got from basic proportionality theorem. Next one. Next he gave that, so this EO is parallel to DC. Now we have to consider the triangle ADC. From triangle ADC, EO is parallel to DC. Now AE divided by ED. AE divided by ED is equal to AE divided by ED is equal to AO divided by OC. AO divided by OC. This is equation number 2. This also we got from basic proportionality theorem. From 1 and 2 we can observe that AE by ED, here also AE by ED. Now these two values are equal. That means BO divided by OD is equal to AO divided by OC from equation 1 and 2. Now here AO divided by BO we have to find. So here by cross multiplication, so BO will come down. That means AO divided by BO is equal to OC divided by OD. Question number 6. The diagonals of a quadrilateral ABCD intersect each other at the point O such that AO divided by BO is equal to CO divided by OD. Then show that ABCD is a trapezium. So we have to show that the quadrilateral is trapezium. That means first we have to draw the quadrilateral like trapezium. This is ABCD. This is a given quadrilateral. The two diagonals AC and BD intersect at the point O. So given that AO divided by BO is equal to CO divided by DO, implies from this we can write AO divided by CO is equal to BO divided by DO by cross multiplication. So this is equation number 1. By construction, so here construction is EO, that line is parallel to AB. So this line EO is parallel to AB. Now from the triangle ABD, EO is parallel to AB. From triangle ABD, EO is parallel to AB. Now AE divided by ED is equal to BO divided by OD by using basic proportionality theorem. So here from this triangle AE divided by ED is equal to BO divided by OD. So by using basic proportionality theorem. From this we can write, so here BO divided by DO, BO divided by DO. In place we can write the same thing. AO divided by CO is equal to AE divided by ED. So from equation 1 and 2. Now just observe that AO divided by CO is equal to AE divided by ED. From triangle ACD, I am doing here, from triangle ACD we got AE divided by ED is equal to AO divided by CO. That means AE divided by ED is equal to AO divided by OC. That means here the line EO divides these two sides AD and AC in the same ratio. By using converse of basic proportionality theorem, EO is parallel to AB. Implies EO is parallel to this one DC. EO is parallel to this DC. By using converse of basic proportionality theorem. Now EO is parallel to AB by construction, this one, and EO is parallel to DC. From these two we can get that one, AB is parallel to DC. In a quadrilateral ABCD, one pair of opposite sides are parallel, then the quadrilateral becomes a trapezium. So implies the quadrilateral ABCD is a trapezium. Question number 7. Prove that a line drawn to the midpoint of one side of a triangle parallel to another side bisects the third side. That means first we have to draw a triangle. Now this is A, B, C. A line drawn to the midpoint of one side of triangle. That means, so let D be the midpoint of AB. Line drawn through this point, that means DE. So AD is equal to BD. That is the given information. And triangle parallel to another side. That means this is the second side. Now this DE is parallel to this BC. We have to prove that that line bisects this AC. That means DE bisects AC. From triangle ABC, given that AD is equal to DB and DE is parallel to BC. this line DE is parallel to BC. By using basic proportionality theorem, BD divided by DA is equal to CE divided by EA, and BD divided by DA is equal to CE divided by EA from basic proportionality theorem. And AD is equal to DB, he gave this one. Now AD is equal to DB, implies these two values are equal. So here BD divided by, in place of AD we can write BD only. So BD, that is equal to CE divided by EA, both gets cancelled and this value is equal to 1, implies CE divided by EA is equal to 1, implies CE is equal to EA. This EA will go that side and this becomes CE is equal to EA. CE is equal to EA, we got that one. That means E is the midpoint of AC. From this, E is the midpoint of AC. From this we can write DE bisects AC. Question number 8. Prove that the line joining the midpoints of any two sides of a triangle is parallel to the third side. First, we have to draw a triangle ABC. The line joining the midpoints of any two sides of the triangle. That means let D be the midpoint of AB and E be the midpoint of AC. Now AD is equal to DB and AE is equal to EC. This is the given information. We have to prove that this side DE is parallel to BC. Now, from triangle ABC, first we have to consider this side ratio BD divided by DA. BD divided by DA. That is equal to, both the values are same. That means BD divided by DA is nothing but BD only, same values. So that is equal to 1. Implies BD divided by DA is equal to 1. And from that side, AE divided by EC. AE is equal to EC, we know that one. So AE divided by EC. From the down I am taking here CE. CE divided by EA is equal to CE divided by EA is nothing but CE. So CE will go, that is equal to 1. Implies CE divided by EA is equal to 1. So here BD by DA is equal to 1 and CE by EA is equal to 1. From these two we can write BD divided by DA is equal to CE divided by EA. Now in triangle ABC, BD divided by DA is equal to CE divided by EA. That means this line DE divides the two sides in the same ratio. By using converse of basic proportionality theorem, DE is parallel to BC. So here implies DE divides the two sides in the same ratio. Implies DE is parallel to BC. So here the reason is converse of basic proportionality theorem. This is the result. Next theorem. If in two triangles corresponding angles are equal, then the corresponding sides are in the same ratio and hence the two triangles are similar. First draw the two triangles. In the theorem statement he gave that the corresponding angles are equal. So this angle is equal to this angle and next this angle is equal to this second angle and the third angle is equal to here this third angle. The given information. These two triangles have the equal angles and we have to show that the sides are in the same ratio. If you consider A, B, C and this is P QR. Now angle A is equal to angle P, angle B is equal to angle Q, angle C is equal to angle R. We have to show that AB divided by PQ is equal to BC divided by QR is equal to AC divided by PR. For this, we have to construct a smaller triangle here. So AB, this length, we have to mark on this line PQ, and this is equal to S. Now here the length AB is equal to the length PS, and now the length AC is equal to the length AC here. Now from this triangle we have to join this to ST. Now angle B is equal to angle Q, angle C is equal to angle R. So this side AB is equal to PS, this length is equal to this length, and AC is equal to this PT, and the corresponding, and these two angles are equal. Now from triangle ABC and triangle PST, by using SAS congruence triangle, these two triangles are congruent. Now angle B is equal to angle S, CPCT, corresponding parts of congruent triangles, and angle C is equal to this one, angle T. And we know that angle B is equal to angle S and angle B is equal to angle Q. From this we can say that angle S is equal to angle Q and angle T is equal to angle R. So these two angles, corresponding angles are equal, implies this ST is parallel to this QR. I am writing the steps. Construction. So PS is equal to, mark a point S on the line PQ such that PS is equal to AB and PT is equal to AC. Now from triangle ABC and triangle PST, from these two triangles AB is equal to PS by construction, and AC is equal to PT, this also by construction, and angle A is equal to angle P, that's the given information. By using SAS congruency rule, those two triangles are congruent. By using SAS congruence rule, triangle ABC is congruent with triangle PST. Now angle B is equal to angle S and angle C is equal to angle T. So next one, BC is equal to ST. The reason is CPCT, corresponding parts of congruent triangles. We know that angle B is equal to angle Q and angle C is equal to angle R. So this is the given information. From these two we can write angle B. So that means angle S is equal to angle Q, implies angle S is equal to angle Q and angle T is equal to angle R. So these two angles are the corresponding angles, and corresponding angles are equal, implies ST is parallel to QR since corresponding angles are equal. Now by using BPT, PS divided by SQ is equal to PT divided by TL. From triangle PQR, so PS divided by SQ is equal to PT divided by TR. So from basic proportionality theorem, we can write this one. So PS divided by SQ plus 1 is equal to PT divided by TR plus 1. So we have to convert this SQ as the full term, that is PQ. First we have to reverse this one. So that means SQ divided by PS is equal to TR divided by PT. Now you have to add 1 on both sides. Plus 1, that is equal to TR divided by PT plus 1. SQ plus PS. taking LCM, SQ plus PS divided by PS is equal to TR plus PT divided by PT. Now SQ plus PS, that is the total value PQ. PQ divided by PS is equal to, so here TR plus PT, that means total length PR divided by PT. We can reverse again, implies PS divided by PQ is equal to PT divided by PR. In place of this PS, we have to write AB divided by the total length PQ is equal to, so here in place of PT we can write AC divided by PR. So this is equation number 1. So here AB divided by PQ is equal to AC divided by PR. So we got equation 1. Similarly, we can get AB divided by PQ. AB divided by PQ is equal to BC divided by QR. BC divided by QR. So this is equation number 2. From 1 and 2 we can write AB divided by PQ is equal to BC divided by QR is equal to AC divided by PR. So the ratio of the corresponding parts of the two triangles is same. So hence we can say that triangle ABC is similar to triangle PQR. Therefore the corresponding sides are in the same ratio, and we can say that from this triangle ABC is similar to triangle PQR.